look at the set of diagrams. It shows the parent function, which is the basic one. And then we want to describe how to translate it to get it to shift from the parent to this new function, the second function that's drawn on there. So if you look at the first on the left-hand side, Virginia, what would that parent function be? This one right here. Yeah, that's parabola, just y equals x squared. Okay, so now we want to look to see how does it translate. And in order to get that, you need to think about the vertex because it's pretty much where you focus a parabola on. So how do you get the current vertex, which is at 0, 0, to move to the new 4? And then we also want to know, is there a vertical stretch or a vertical shrink that we have to worry about as well? So let's just talk about the shifting first. Brandon, how does the vertex shift from the parent function to the new one?
It goes right 2 and then down 3.
Yeah. So right 2, down 3. So how would you write that then, Brandon?
F of x equals 2x squared minus 3.
So if you're moving right, what does that look like when you move right?
It'd be minus 2.
Right, x minus 2 squared, and then you said minus 3. Let me move this guy over more. Okay. So he told me right 2, which really means x minus 2. And then he said down 3, so that's the minus 3. Any questions on that part? So that's the h and the k. H is how far to the left or right any graph moves. The k is how far up or down any graph moves. And you're not like squaring this quantity inside, cubing that quantity. You don't do anything with that h and k. It just tells us how far it shifts. And then we need an a value in front. So the little number in front would be, what's that new vertical stretch? How high is the graph going? And Brandon, do you know that? Why is it 3?
Because normally whenever you move over 1 and up 1, that would be the point, but now you move over 1 and up 3.
Right, nice. So usually you go over 1, 1 squared is 1. But in this case, if you move over 1, 1 squared is still 1, but this bumped up to 3. So you took that 1 value and you multiplied it by 3. So the vertical stretch would be 3. So usually it's over 1, up 1, but now it's over 1, up 3. So we're multiplying by the value of 3. So the transformation equation would be 3 and then x minus 2 quantity squared minus 3. So right and down. Questions? Isha, do you know what kind of equation represents with the second problem?
Is it square root or cube?
Nope, you're right. First one was right. So square root of x, it's just a hook. Hook to the right. And where the little x is where that starts. So at the bottom it shows -4, -2. So that's where the graph is starting. So it's starting at -4, -2, where that x is. Virginia, can you give me the numbers with the translation in it?
Y equals 3 square root of x plus 4.
So she said 3 square root x plus 4, okay, and then minus 2. All right, let's look at this to see how we have here. So plus 4 means we're moving left 4, which in this case we are moving left 4. And minus 2 means we're going down 2. That's good. And then she said 3, because usually you go over 1, up 1, but instead we're going over 1 and up 1, 2, 3. So the 3 in front there, because usually it's over 1, the square root of 1 is 1, so I move up 1, but now we're going over 1, up 3. So you're multiplying that square root of 1 by 3. Any questions? All right, then the last one. We have these V graphs. Michael, what symbol goes along with our V graphs?
Y equals the absolute value of x.
Yeah. So y equals the absolute value of x. And this one is right again where that little x is where ours goes. There we go. Michael, can you give us the transformation?
I had f of x equals 2, and then the absolute value bars was x plus 1, and then a plus 2.
Nice. So x plus 1 means you're moving left 1, which in this case we did, move left 1. Up 2 for the plus 2 to get to that vertex. And then looking to see from one point to the next. Again, usually it's over 1, up 1 in the original one. But now this new one, it's over 1 and we go up 2. So that's how you get that 2 in front. Any questions? So identify the type of graph you're dealing with. And then look at the translation, the shift. How is that moving left, right, up, or down? Finally, kind of think about what is that vertical stretch. So where was the first point? How is that like first point different? So usually it's over 1, up 1. What are we multiplying by to go up? Questions? Please save that page. Place it like in the pocket or of your binder. Clip it in your binder, wherever you put it. But the front of it kind of will pertain to things that we will continue to go over. So I do want you to keep that. Come back to the rest of it. So I'm going to go over number 4 from the homework, which is really number 5. So it's number 4, part 2, or the second number 4. And hopefully it'll help like clarify maybe like the thought process, what you could be thinking about as you're trying to create these ordered pairs. I do ask that your graphs are labeled. So if you don't label your graph, then have it in T-chart form, have it in some kind of like little, starts at this point, it moves to this point, however you want to write it. But I do need to see like the x and the y values, how they're transforming. So on the graph, it says that it's shown from the interval of -2 to +2. That has nothing to do with your new graph. It's just saying that the current graph has a domain between those 2 points. It doesn't extend any further to the left. It doesn't extend any further to the right. That's the only reason that information is given. So if you look at the second number 4, which really is number 5, so this should be a 5, this one is a 6. We're going to see if we can kind of just work through those steps as to what you should be thinking about as you're trying to create a new graph. So the first thing that I did was I just labeled like the important points of the graph. So the starting point, this point up here is the max. Point down here kind of is the point where it stops decreasing, and that's at 1, 2. And then this second point here is at 2, 2. So those 4 points are the 4 points that I'm going to focus on translating or transforming based off the information. So with number 5, we have -2 f of x and then +4. So Chelsea, just describe how would number 5 transform? What would happen to the graph?
It's times by -2, so it's wider.
So the y variable, because it says -2 f of x is the same thing as saying y. So you're taking -2 times the y variable. And then what else are you doing, Chelsea? What's that +4 do?
And then you go up.
And you go up 4. So that's still y because y is moving up or down. So after you multiply y with -2, you're then adding 4 to that value. Chelsea, does anything happen to x? No. Because is anything in parentheses with x? If I could erase this. Here we go. So, it's like a joke right there. If nothing's in parentheses with x, x isn't changing. So in this case, nothing in parentheses with x doesn't change. So if you were asked to write like a little formula for what to do with your ordered pairs, this would be a little formula or a pattern to use. X stays the same because nothing's in parentheses with x. However, the y value gets multiplied by 2, negative 2, because it says negative 2 times f of x, and y gets a plus 4 with it because it's moving up 4. So if you look at number 4, like x is changing because there's stuff in parentheses. Number 6, x is changing because there's stuff in parentheses. Number 3, and number 1. So 1, 3, 4, and 6 only affect x because there's parentheses with x and something's different inside. If it's outside, then your y changes. So it's something to kind of remember. If it's inside, it changes x. If it's outside, it changes y. So looking at the first order pair, which was up there, it was at 2, 0. So as I said, like feel free to make yourself a T-chart. Here is like the old, this is the new, whatever you want to do, label the points on the graph. But if my old point was 2, 0, and we have to apply this little formula to it, or the pattern to it. So I have currently an x, it's going to stay as an x, so that's going to stay as a 2. If my y value is 0, and I need to transform it by taking negative 2 times y plus 4, what's the new y value going to become? 4, yeah, so the new point is 2, 4. The second point was 0, 3. That was the old point. So Nick, if I plug that 3 in to the little formula Chelsea gave us, what does the new point become? We're going to plug it right in here for y.
Negative 10. Add, 2. I did this wrong.
You did this wrong. That's okay. So we're going to plug in a 3. That gives us negative 6 plus 4 makes us negative 2. All right, so then we'll go to the next point, which I think was 1, 2. And then the last point was 2, 2. So x stays the same. Brandon, what's the new y value going to be? 0, yeah. And same thing with the next one. X stays the same. The y was 2, so it's now 0. So those will be our new points.
You made 2, 4, not like it's negative 2, 4, not 2, 4.
Right here. Thanks. Appreciate it. So then you were asked to graph it, and I'm just going to kind of sketch it over here. So at negative 2, it's now up at 4. That kind of shows us that's like the shift up. It's shifting vertically up 4. The next point we have is 0, negative 2. And then we have 1, 0, and 2, 0. After you have the points plotted, like I really didn't use the graph at all. I don't care what the shape of the graph is. Okay, I'm going to focus on the ordered pairs. Translate the ordered pairs based off the pattern that you can kind of create by looking at the equation. And then go back and connect the graphs so that it looks like the picture. So if you look above, our picture, the current graph, we have this diagonal line with a little bump in it, and then it ends with a horizontal piece. So we're going to try and do that same exact thing. It's flipping upside down because of the negative sign. So that diagonal line is now upside down. We still have that little bump, and we have the horizontal flat piece. So the negative flipped it over the x-axis. It has flipped now over the x-axis. The 2 has stretched it vertically. So if we compare the distance of this little curve to the distance above, you can see that it has been stretched because this one up here was a distance of 1 for that little curve there, and now it's a distance of 2. And same thing with the entire distance of the graph. It's now a distance of 6 from one point to the other, where the other graph was 2. So you can see it's being pulled vertically, it's being stretched. And then everything is also shifted up 4 units. So it flipped, it stretched, and then finally it was pushed up 4 units. Questions? So if you look down below, and these are the ones that seem like I don't think people are too sure what to do with these problems. So it says let f of x equal x squared and g of x be 1 over x. Express each as a transformation of f or g. So essentially you need to pick f or g based off of the equation you're given. When we're writing as a function of f or g, you should no longer have x squared in the problem. You should no longer have a fraction in the problem. You should either have an f or a g with an x and some numbers. So our problems are going to look like the ones that are above. So like our answer should say f of x minus 3. Like that's what our goal is. I don't want the function in there, that x squared in there. I don't want a fraction in there, because we can kind of then look at any notation and say, no matter what the graph, it should move the same exact way based off the way it's written. So if you look at number 1, we have x minus 4 squared, x minus 4 quantity squared. So because it's a quantity squared, Brandon, which letter are we going to refer to?
F.
F. And then if it's in parentheses, it stays in parentheses because it's affecting x. It's moving x left or right. If it's outside the parentheses, then it stays outside because it's affecting the y, shifting it up or down or stretching it vertically. So this would be moving the graph to the right. Well, any graph we move to the right is supposed to be in with the x. So I have f of x minus 4. And that's it. Like there's no x squared. I don't put a squared around that parenthesis because the f represents the squared part. It says refer to the function that was x squared. You need to go back to it to know what to make for the graph. So that's all you're doing for number 7, nothing else. So if you look at number 9, if there aren't parentheses, don't put it with x. If there are parentheses, then it needs to stay with x. Again, it's x squared, so we need that f. There are no parentheses in this problem. So x is all by itself in the parentheses. Brandon?
Plus 5.
Plus 5. And then there was a negative in front of x squared. That x squared is the function. X squared represents f of x. So that means I need to place a negative in front of the function. So there is a difference if this was written a negative x squared plus 5. Then you would have parentheses and a negative inside the parentheses. But if there aren't parentheses, there's nothing sticking that negative with the x. It's in front of the function. So then number 11 says 2 plus 7x squared. So here's my 2, there's the plus, there's the 7. X squared is the function f of x. Again, no parentheses, nothing different inside with x. Questions? Okay, so then if we look at number 8. Number 8 switches forms. It's now that fraction form, so we need to use a g. Is the 3 connected to the x? No, because it's not on the bottom. So nothing is with x if it's not on the bottom. So 1 over 3x is different from 3 over x. If it's with x, it stays with x in parentheses. If not, it goes in front of your function. So this is not equal. However, if I had 3 times 1 over x, that means the same thing. Because you're taking 3 times 1 over x, or 3 over x. They mean the same thing. Any questions? So looking at number 10. Number 10 is the first one here. The x is in the denominator. The minus 1 is with the x. So really they're like invisible parentheses sitting there, because it's with x. And if it's with x, then it goes with x. Again, like you could see 1 over x and the minus 1 separately. That's what it would look like if you're writing it after the parentheses. So just to kind of get you an idea of what it would look like with x, what it would look like if it was with y. And then the last one, again, parentheses grouped with x. So you could write it just as it states down there. All of that stuff is with x. Or you could pull out the negative 2 and say x minus 1. Because that's really how we would decide how to shift the graph. by pulling out whatever number was like distributed through. So this graph is really going right 1, and then that -2 is giving us a translation. Yes.
On a test, how would you want it?
Either way is fine, but if you were asked to describe the transformation, you probably want to pull out that -2 so you can give the correct transformation. Are there questions? Hopefully that explains it a little better. Maybe it makes it a little clearer. If you just flip in your packet one more page. So I passed out what I think is maybe better graph paper for these problems. I passed it out at the beginning. It gives you a little more space in between the boxes so that they're not like squished together, and I think your graph will look a little closer to what the original graph is that you're given. The first group of problems are the ones that you're going to graph on graph paper. And again, like the current domain starts at 0, it goes through 2. Your new graph will go beyond that domain depending on whatever you're asked to do. But just look at number 5 here. So I want to make sure you can write like the little pattern. So number 5 says 2 f of x plus 1 and then plus 3. If you were asked to write that, like how does it change x, how does it change y? So like what happens with your x coordinate, what happens with your y coordinate? So see if you can think about that 2 f of x plus 1 plus 3. Ooh, there it is. What's happening with x? How's x changing? Chelsea?
It goes left 1.
It goes left 1. So when we think something goes left 1, that means you have to take your x and subtract 1 from it. Because that's how you get something to move to the left. Chelsea, what's happening with y?
It's you multiply by 2 and then.
Right, multiplying it by 2 and then adding 3. So when you're thinking about graphing number 5, like this is what you want to do to your x. Subtract 1 from all the x's. The y values are first multiplying it by 2 to get the stretch, and then you're shifting it up 3 to move it vertically. The second set of problems kind of deals with reflections. So if you reflect across the y-axis, think about your x and your y. Again, think of it as a point. What changes with x, what changes with y? Part B says reflected across the x-axis. So again, what changes? So if you can think about how it should change, then you should be able to kind of think of what the equation or what the graph should look like. And then the last one, for example 7, dealing with even and odd functions. So what happens if you have an even function? If this is my current graph, what can I do to make it even? Again, think about how x and y change. So think about that change to x and y. You have about 9 minutes, 10 minutes to get started. I'm going to go around and pass back your quizzes from last Thursday. But try and get maybe 1 or 2 of those graphs done. Tomorrow we will review